In this experiment, the Archimedes principle will be applied. This principle states that any body that is submerged experiences a vertical force called a buoyant force. This force is equivalent to the weight of the fluid displaced by the body. It also states that the displaced volume of the fluid will be equal to the total volume of a completely submerged object. This can be used to measure the volume of an irregular object.
For our first experiment, we're going to be using a regular object. This is because we need to obtain the value of the object, multiplying it by height, by width, by length. The value of the object will be our theoretical value. It's the one that we're going to compare to the experimental value, which is the volume of the water displaced, to prove Archimedes' principle and the effectiveness of our experiment. We also need to measure the volume of our container. In this case, we're using a cylinder, one, clear, but you can use any container that you can obtain the value of. To obtain the value of our cylinder, we're going to measure the diameter, so we can get the area and multiply it by the height. Then we're going to measure the height of the water inside our cylinder without any object in it. After we get these values, we now can submerge the object into the water. The object has to be completely submerged so that the principle will apply and the experiment will work. And then we get the height of the water, and now with these values we can compare the difference in height. Finally, to get the volume displaced, we have the volume of the container minus the area of the cylinder and the height of the water displaced.
As you can see in the image, we subtracted the change in height and the area of the cylinder from the volume of the water to get the volume displaced, which can be compared to the volume of the cube. That ended up being very similar. We got 3.58 times 10 to the negative 5 for the volume displaced, and we can compare this to 3.28 times 10 to the negative 5, which is the volume of the cube. We ended up with an error percentage of 8%, which is low and confirms the theory. However, there was an error probably because of a mistake made during measuring.
Okay, so our next objective is to get the volume of this little truck. So our first step is going to be to measure the height of the water. As you can see, we already have the measurement right here on the board. Now, what you need to do is introduce whatever object you want into the water so that you can get the volume. We're going to go ahead and put it in, just like that. And now we're going to measure the difference in height from this one to this new height from right here.
Now that we have the height of the container when the object is fully submerged, we can get the volume of the object. To get the volume of the object, we're just going to multiply the area of the base times the difference in height between the original container and the container that has the object inside. To get this difference in height, we're just going to subtract the original height to the new height when the object is inside. This is going to be 0.07, which is the height when the object is fully submerged, 0.07. And we're going to subtract the original height of the water, which is going to be 0.0685. This will give us a difference in height of 1.5 times 10 to the negative 3. Then we have to multiply that times the area of the base, and it's going to give us the volume of the increment in water, just this little piece. But this volume has to be equal to the volume of the object. So after calculating the area of the base, which is only going to be pi times radius squared, we get an approximate volume of 8.91 times 10 to the negative 6 meters cubed.
The Archimedes principle can be found in many daily situations, such as placing pasta in boiling water, placing ice in a glass of water, doing the laundry, and even when we step in a puddle. Based on this experiment, we can conclude that the volume of the displaced fluid is equal to the total volume of a completely submerged object,